Okay, welcome to JTT Math Easier, and this will be talking about Calculus 2, and it will be about inverse trig functions and integration. So like I said before, you're going to have to know this table. It can become very helpful, and I'm pretty sure on your exams and quizzes or whatever they give you in class that you will have to know these formulas because they will be used throughout a lot of the integrations. Okay, so you have your arctangent, your arcsine, and your arcsecant. So this is the question we have. This one's a little bit different than the rest of them because this is the main fact that this is a match with one of those formulas I was given to you, right? Especially the down part. So, in this section it talks about completing the square, and also in direction it says hint, complete the square. So what we're going to be doing is completing the square. So you have x squared minus 2x plus 2. You can put 0. In order to complete the square, we're going to want to move down. Move 2. You go x squared minus 2x. Leave a blank here. I'll tell you why. Just in case, if you guys know how to complete the square, this is good. If you guys don't, it's a really good refresher. Minus 2. I'm sorry. So, what you do is you go negative 2 divided by 2. You might want to ask why 2? It's always going to be divided by 2. Let's say if you have a 10, it'll be divided by 2. 14, 15, 16, whatever number they give you, it will be divided by 2. And then you always have to square it. Whatever your answer is, then square it. So obviously this would be 1 plus 1 plus 1. So you go 2x minus, x squared minus 2x plus 1 equals negative 1. So this is 10 times more easier to complete the square than using this. It's a little bit more difficult, even if you have one of those super smart calculators. Sometimes it won't give you it will give you like a decimal and it's wrong. So this is x minus 1 squared equals negative. I know some of you guys might be like, oh, let's just divide it so we can get rid of it. But what you do is that you actually just move it to this side. Then this is your new bottom denominator. So you go 0 over 2 dx 1 plus x minus 1 squared. Okay, so obviously this is a lot easier to work than with this that we had previously. And here you want to label your A and a U if it helps you. It helps me. So this is obviously going to be my A. And it's always going to be my U. The way you figure out which one is your A and U, you usually always tend to have the square. Your A will have it. I'm sorry, that's not the way. The way you always know it is that your U always consists of X, and your A is always a number. So, obviously this one matches, this integration matches the arctan, which is 1 over A arctan of U over A plus C. But since we do have endpoints, we don't have to add the plus C. The only time you add plus C is when you don't have endpoints. And I'm telling you that it goes on forever unless you're given endpoints. So your A, like I said earlier, is 1. So you could do 1 over 1. It doesn't really matter. Arctan of U is x minus 1. And then your endpoints are 0 and 2. And the way you do this is you plug it in. Arctan of 2 minus 1, which is obviously 1, minus arctan of 0 minus 1. And when you plug it in your calculator, you should get the answer of pi over 2. And that is your solution. Hopefully this helped you out, and just remember to remember the table I was telling you about earlier. Thank you!